Electrical distribution boards, DBs, are critical components in building electrical systems. They act as central points for receiving power from the main distribution panel and distributing it to various electrical loads within the building. The termination of circuits in an electrical distribution board will depend on the specific requirements and design of the building. Below are some general guidelines for the termination of small power, lighting, UPS, and HVAC circuits in a typical electrical distribution board. Small power. Small power generally refers to electrical outlets and other low-power devices used in offices, homes, and commercial spaces. The termination of small power circuits involves connecting the live, phase/hot, neutral, and protective earth-ground wires of each outlet or device to the distribution board. These circuits are protected by circuit breakers or fuses to prevent overloads and short circuits. 1. Small power refers to electrical circuits that power low-consumption devices and equipment such as computers, printers, small appliances, etc. These circuits are usually supplied by standard electrical outlets. Termination. Small power circuits are connected to the distribution board using appropriately rated circuit breakers or miniature circuit breakers, MCBs. The MCBs are installed in the distribution board, and each MCB corresponds to a specific small power circuit. Lighting. Lighting circuits supply power to light fixtures such as bulbs, fluorescent tubes, and LEDs. The termination of lighting circuits is similar to small power termination, where the live, neutral, and protective earth wires are connected to the appropriate terminals on the distribution board. Lighting circuits can be grouped based on the area they serve or the type of lighting, for example, general lighting, emergency lighting. 1. Lighting circuits provide power to various lighting fixtures, such as overhead lights, wall sconces, and other illumination sources throughout the building. Termination. Lighting circuits are also connected to the distribution board using circuit breakers or MCBs. Different lighting circuits are typically separated to allow for better control and management of the lighting in different areas or zones of the building. In some cases, lighting circuits may be connected to time switches or dimmer switches for additional control and energy efficiency. UPS, uninterruptible power supply. UPS systems provide backup power to critical equipment in case of a mains power failure. The termination of a UPS system involves connecting the UPS output to the essential loads, for example, servers, computers, medical equipment, through dedicated circuits. Usually, the UPS output is connected to specific circuit breakers in the distribution board, which supply power to the critical loads. 1. A UPS system provides backup power to critical equipment in the event of a mains power failure. It is commonly used to ensure continuous power supply to essential devices like servers, data centers, emergency lighting, etc. Termination. The UPS system is typically connected to a dedicated circuit breaker in the distribution board to ensure that it is protected from overcurrents. The critical equipment or loads that require UPS backup power are connected to a separate UPS output distribution board, which is supplied by the UPS system. HVAC, heating, ventilation, and air conditioning. HVAC systems, which include heaters, air conditioners, and ventilation equipment, have specific power requirements based on their capacity and function. The termination of HVAC systems involves connecting the electrical supply lines to the appropriate circuit breakers in the distribution board. Some HVAC systems may require dedicated circuits with higher current carrying capacity due to their power demands. 1. HVAC systems include heating, cooling, and ventilation equipment, which may require significant electrical power. Termination. HVAC systems with high power demands are typically connected to the distribution board using circuit breakers with appropriate current ratings. In some cases, larger HVAC systems might have their dedicated distribution panel to manage their power requirements separately from other systems. It's important to note that electrical installations can vary widely based on local electrical codes, building requirements, and specific project designs. Thus, it is essential to consult with a qualified electrical engineer or professional for the appropriate design and installation of electrical distribution boards for specific applications. Additionally, local regulations and standards should be adhered to during the installation process.